Difference of squares, sum of squares, difference of cubes, sum of cubes.
Difference of cubes.
Very good. Once you say the difference of cubes, you prepare a binomial and then a trinomial. Perfect. What is the binomial? Keeping in mind that there is a minus, I have to have a minus here and I have to have a plus. It's minus minus plus or plus plus minus. So what are the two terms in the binomial?
X minus a third.
Very good. Who was that?
Axel.
Thank you. Good. Now here it's very easy. You square this and you put it here. You multiply these two and you put it here. You square this and you put it here. That's the pattern. We have it right here. I square this, I multiply these two, and then I square this. So let's square the first term.
X squared.
Good. Let's multiply these two.
1 over 3x.
Excellent. Plus, let's square this piece.
1 over 27.
You meant 1 over 9, I know that for sure. Excellent. That's it. If you try to distribute this to these three terms, this to these three terms, you will see 4 terms will go away and you will end up with these two. Okay, moving on to trinomials. With trinomials, I have to start with the same way. Descending order, greatest common factor, negative leading coefficient. Then I will continue with the possibilities for a trinomial, because it's not a binomial, it is not a polynomial. What are the options here? The two, what we already talked about when we square that binomial. I don't remember where it is now. It's right here. So these are two of them. But what about the other two? So these are the two we just discussed. What about these two? Well, we had an example a minute ago, maybe half an hour ago, I should say, which was this. When the leading coefficient is 1, leading coefficient 1, we're going to have examples in a minute of all of them. And the last option is when the leading coefficient is not 1. So one more time, these two are the two special products that we discussed. This one we had one example, we're going to have another, and this is the most difficult one, and I want to emphasize this one now, but going through a couple of examples. So I'm going to share my screen and let's choose. Okay, so the special products are here. So let's try any of these as an example. Then 1 as the leading coefficient, that's the second, so this is one option when the special product works. If the special product doesn't work and the leading coefficient is 1, then we have a technique that we just used on one of the examples. And when we have the leading coefficient which is not 1, these are the most difficult ones. That's it. There is nothing else more difficult, and this is always very easy when we look at polynomials. So let's take it easy and let's choose a problem here. I would like B, but you can choose any problem. Any preference?
B is fine.
Okay, very good. Thank you. So negative 3x squared minus 12x minus 12. Perfect. I have to go through the steps. Is it in descending order?
Yes.
Perfect. Greatest common factor, negative leading coefficient. These can be in one step. Greatest common factor and negative leading coefficient.
-3.
Excellent. What is left in parentheses? Remember, we have three terms. We have to write three terms inside. So what do we have left in there?
X squared plus 4x plus 4.
Excellent. So -3. Now, at this point, I will always try the special products, which are a plus b everything squared or a minus b everything squared. Since the middle term is positive, this cannot be. But will this one work? Is there something that I can write and square as a binomial squared to get x squared plus 4x plus 4? And the answer is
X plus 2.
very good. We should always check the middle term. This one. How do I check the middle term? Well, I know that x squared is x squared. I know that 2 squared is 4, but I have to check the middle term. 2 times the first times the second. Oh yeah, okay. It's 4x. 2 times the first times the second is 4x. So this is the correct factor form of this. Now let's see what happens if a special product doesn't work. So now let's choose from here. I like to choose D. Again, quickly, once you get used to this, it's going to be like second nature. Descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, yeah. Yeah, it's a special product. X plus 6, everything squared. And you should say not so fast. What is that I did not do? There's one step that I did not do. What is the step that I did not do? There is something that I skipped. What did I skip? Anyone? What do you think? Is this correct?
You check the middle.
Exactly. I did not check the middle term. What is the middle term here? Excellent. What is the middle term here? Two times the first times the second. What is the middle term?
12x.
Good. Do I have 12x here? Is this 12x?
No.
No. The special product doesn't work. There must be something else. The leading coefficient is 1. So that's a nice one. So this is always the sum of two numbers. And this one is always the product of two numbers. So I can immediately state that since everything is positive, obviously both will be positive. But I need two numbers whose product is 36 and whose sum is 13. Same two numbers. Their product is 36 and their sum is 13. Once I found these numbers, I found my factored form. Can anyone come up with two numbers whose product is 36 and whose sum is 13?
9 and 4.
That's it. It takes 10 seconds to check. X squared plus 4x plus 9x plus 9 times 4, which is 36. Yes. Kevin, go ahead. Anyone, any questions? Any questions? Do we need another example like this, or we move on to the last one in trinomials, which is this, the most difficult one? Do we need another example? Is it a yes? Is that a no? Please help me so I know what to do.
C.
You want C, the x squared minus 4x plus 4?
Oh, I was talking about the other C.
Okay, perfect,
We weren't
perfect.
there yet.
Yes, perfect. So let's move on to the last one. Very good. So you wanted C, very good. 5mn plus m squared minus 150n squared. Awesome. Good pick. So the first step here is to arrange it in descending order. And you can say based on what? It doesn't really matter, but the easiest step will be to rearrange it as m squared plus 5mn minus 150n squared. Well, it turns out that the leading coefficient is 1. This is not a special product, because a special product in binomials has to have positive on the last term. It doesn't. It has negative. So it cannot be a special product. So quickly, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, no, because the last term is negative. 1 is the leading coefficient? Yes. So therefore, I'm looking for two numbers whose product is this, negative 150, and whose sum always is the middle term. Now, because one term is because the product is negative, one has to be positive and the other one has to be negative. Mandatory. Here, everything was positive, so therefore, positive is the only option. But since the product is negative, one has to be positive, one has to be negative. And now we have to think and find two numbers whose product is negative 150, and when we add them up, the negative number is smaller in absolute value, so we can get a positive 5. Can anyone come up with two numbers whose product is negative 150 and whose sum is 5? And of course, one has to be positive and one has to be negative.
Is it 15 and negative 10?
15 and negative 10. I meant to put it here. The product is indeed negative 150, thank you so much, and the sum is indeed 5. And that's it, that's all we needed to do. So the answer is M15n and M5n. It takes 5 seconds to check. M times M is M squared. Negative 5n mn plus 15 mn, 5 mn, negative positive 15n times I talk too much. So m squared, negative 10 mn plus 15 mn is 5, and 15n times negative 10n is negative 150n squared. Okay, finally, the last one. Last type, when the leading coefficient is not 1 and no special product is applicable. Anything that you'd like to pick. Anything? Okay, I will pick A. 6y squared minus y minus 1. Quickly through all the steps, descending order, greatest common factor none, negative leading coefficient none. It's not a binomial, it's a trinomial. I try the special products, no, because the free term is, or the last term is negative, no. 1 is the leading coefficient, I wish, no. My last chance, when no special product is applicable and 1 is not the leading coefficient, so this is the last one. In this case, this becomes the product. We have to involve the leading coefficient. And this is still the sum. Nothing changed there. So we're looking for two numbers whose product is negative 6 and whose sum is negative 1. Since the product is negative, we expect a positive and a negative number. Can we find two numbers whose product is negative 6 and whose sum is negative 1? Anyone?
Negative 3 and 2.
Negative 3 and positive 2. When I multiply them, I get negative 6? Yes. When I add them, I get negative 1? Yes. But here's what happens next. So you're going to see, I quite often, I want my students to understand that this continues somewhere and you can skip over this. So we will continue here so I don't have to start and write it again. At this point, I will replace the middle term by these. So I still have 6y squared, but now I have plus 2y minus 3y and minus 1. At this point, I factor by grouping. From the first two terms, so here's a triangle now. What will you factor out from the first two terms?
The y.
More?
2y.
Excellent. What is left in parentheses?
3y plus 1.
Very good. What should I get from the other two? I'm not even looking. I'm not going to look before I write. What should I get from the other two in parentheses so I can continue? If I don't get that in parentheses, I will not be able to continue. And I know it's factorable because I found the numbers. I found two numbers whose product is this and the same numbers whose sum is this. I know it's factorable. What do I have to have here before I look? Otherwise, I can't continue.
The same thing, 3y plus 1.
Exactly. Thank you so much. Who was that? John? Okay, good. Very good. If I don't get the same thing, I'm not on the right track. I made an error. Something is wrong. Now I look. What do I factor out so that I do have 3y plus 1? I cannot fabricate it. It has to be there. So what do I factor out from these two terms so that I have 3y plus 1 in parentheses?
Negative 1.
That's it. You don't have to write it, but I'm going to write it just because we normally don't write a negative 1 in front. Awesome. What do I factor out now from these two? What comes out from these two? I know it's silly, but I just want to emphasize what comes out. What is the common factor now?
The 3y plus 1.
Indeed. And what is left once we take this out? I have my props, as you see.
2y minus.
That's it. It takes 5 seconds to check. 3y times 2y, 6y squared. Negative 3y minus 2y is negative y. And positive 1 times negative 1 is negative 1. Of course, if you are used to using a different method here, I'm fine. Just compare the two methods. If you still find that yours is easier, use it.